In this short video, I'm going to take you through a step-by-step guide into how to calculate Spearman's. This table shows you what statistical test, a non-parametric one, to use when. You can see that for Spearman's, it's a test of a relationship with a correlation with ordinal data. So the formula for calculating Spearman's rho looks quite scary, but actually it's not that bad once you break it down into stages. So let's have a look at an example. So what's the relationship between personal preferences for two groups? So Slipknot and Blue, for example. Participants have been asked to rate these two bands out of 10. So 10 being they're my favourite to 1 or 0 being I really don't like them very much. Now you would expect there to be a negative correlation, and if you look at the data when it's been put onto a scatter graph, that is indeed what it shows. In other words, if someone likes Blue, they don't like Slipknot very much, and vice versa. So we can tell we've got a negative correlation, but what we need to know is how strong that relationship is. What's our correlation coefficient? So our first stage in calculating Spearman's rho is to rank the data. So ranking the scores for each of the co-variables. So we've got our data there. The first thing we do is to put it into order and then give it a rank value. So if you look at the scores for Blue, the highest was a 10, so I've given that a rank value of 1. It was first. You can see that 2 participants scored it 8. That means it's a shared rank between 3 and 4, so it becomes both of them are 3.5. They are tied ranks. But note the next value of 7 then gets the value of 5 because you've used 3 and 4. So that's how you rank it. You do exactly the same for Slipknot, rank theirs. Now what's really important is when you put it back into the table, you keep the participants' scores together. So you've got to put them back into the order they first were. So you can see here, participant 1 ranked Blue 4, so that got a rank value of 8, and Slipknot 9, so that got a rank value of 1.5. What we need to calculate is the differences between the ranks. So 8 take away 1.5. So you can see 8 take away 1.5 gives us 6.5, and 6.5 take away 3.5 gives us 3, and so on. Now note we've got some negative values. So one of the things that we do to help us to be able to calculate more easily is we square everything so that everything becomes a positive. So 6.5 times 6.5 is 42.25, etc. Once we've done that, we then add up. That sign, sigma, means sum of. So sum of differences squared is 290.5. We then need to take this value and substitute it into our formula. So you can see you've got 6 times sum of difference squared divided by n, open brackets, n squared minus 1, close brackets. Now our sum of differences squared was 290.5, and we had 10 participants, or 10 pairs of scores. So 10 times 2 is 100, minus 1 is 99. So 10 times 99 is 990, and 6 times 290.5 is 1743. So if we divide 1703 by 990, we get an answer of 1.76. Now remember the first bit was 1 minus. So 1 minus 1.76 equals minus 0.76. Now hopefully you can already see that that shows quite a strong negative correlation, which is also what the graph was showing us. So we now need to know what that means in terms of our critical values. So we look up the critical value. N is 10. It's a at the 5% level, and it's a one-tailed test. Now our critical value is 0.564. This means our result is statistically significant and we found a negative correlation. Therefore, we can reject the null hypotheses. So we can be quite confident saying there was a negative correlation between participants' preferences for blue and Slipknot. When we look at the table, if you look at a one-tailed test for 5% with 10 participants, you can see there 0.564. One thing to remember though is the sign, because remember we found a negative correlation, minus 0.76. That sign, when it comes to correlation coefficients, doesn't have a numerical value. It simply indicates whether the correlation is positive or negative. Therefore, 0.76 is greater than 0.564. I've often found students get confused and think, well, it's a minus number, surely it's less than. But remember, that minus is only telling us it's a negative correlation. Thank you for listening to me, and I hope you found this video useful.